I'm going to give you a quick rundown on how to work through the problems on your next assignment. This is the example from the assignment. It's got the total load, reactions, moments. You've already done this. That should be pretty easy to work through that. The new calculation here is the section modulus, which is the measurement of the resistance of a beam to bending. That's maximum moment divided by allowable bending stress, which is, for what we're doing, we're going to be using the same type of steel throughout, and that's always going to be this 24,000 psi. So when you take your maximum moment in inch-pounds divided by your allowable stress, bending stress, you'll get your section modulus. When you get that number, you're going to go to this tab on your workbook that says Standard Beams W. That's a W-shaped beam. There's also an S-shaped beam they talk about in the text, but for this first set of problems, we're just going to use the W-shaped beams. So you go over there, and then you look through this your section modulus column, which is right here, and you find we had 32.1. In the book, it uses a different beam number than I'm going to show here, but I grabbed this table here from this site, which also has a diagram of your beam, which you'll use that in SolidWorks to make the beam in SolidWorks and apply all your forces, and it should help you check your work as you're working through these problems. So we got 32.1, so you want the number larger than that. So we got 32.4 here. Which would be a 10 by 30, or, so that's 10 is kind of the height, and then 30 is the pounds per linear foot. When you're selecting these, let's always kind of lean towards the lighter ones. So this W12 by 26 will be a lighter beam. So we'll select that one, and we'll come over here. Once you have that number, you can come in here, and there's a drop down with all the list of all of the different beams. So we wanted 12 by 26. There it is. And so if we look back at, as I said, this diagram here, D, BF, TF, TW, all those numbers are right here. So that should help you put your beam into SolidWorks. So if I go here, I got these two sketches already completed. So here's my I-beam. I got my units are in feet. If you have yours in inches, just make sure you're putting in everything right for that. So there's the beam shape, and then I have this other sketch here for the length of the beam and the position of each of the forces, the loads. So I'm going to select this one and extrude it. I'll use up to vertex on my sketch here, up to vertex on that one, and there's my beam. You also can use that secondary sketch here to, if you ever have distributed loads in different spots, you can kind of section out your beam using this sketch too. Okay, so I'm going to start my new feature, new study. Static 2 is fine. Click there. Same method as the last set of problems. We'll apply our material. But this time, let's find the A36, ASTM A36 steel. We'll use that one. Hit apply, close, treat as beam, fix geometry. Here and here, make them immovable. External loads, force. We have on the example, shoot. I thought I put those. I did. Oh, those aren't showing. Here we go. 8,000 pounds. On that point, Reverse direction, check. Force. Let's pin that. Front plane. 8,000. Check. And then we have a distributed load of 7,200. Unpin it, check. Now when I run my study here, you can see my max PSI here is below 24,000. So if you can see that's under, if this number is going to be under 24,000, then you know your beam's right. You can still run all of your shear and moment diagrams to double check that side of your work, but when you're working through these problems, all I need is the maximum moment, the section modulus, and the beam selection. So if you have any questions, let me know. I can make another video or obviously walk you through it during class.